Okay, so we're going to work two, oh, come on. Dang, we were doing so good. Last period, that thing did not disconnect, not one stinking time.
I feel like that was looks like a signature, like why you did that.
Okay, so he must be, I'm going to just turn him off. Alright. Oh, that's okay. Give it just a second. There he goes. He's waiting. Okay, now tap twice. Perfect. Okay, thanks, Alan. Alright, now, so, two problems. Here's the first problem. F of x is equal to x squared minus 9 over x squared minus 2x minus 3. So we're finding all these things. Leave some room on the left so you can show some work. And we're finding domain, range, vertical asymptote, horizontal asymptote, slant asymptote, point of discontinuity, x-intercept, thank you, and y-intercept. We'll make us a little T-chart down here if we need it, and I will put my graph. Okay, so tomorrow when I'm not here, there's no telling who you're going to get first up, right? The odds are they probably won't be able to do this. So y'all help each other, okay? Don't work together, because that's not helping. But if someone needs some help, please stop for a second and help them. Don't just go, oh, well, I need to get my work done. So help others. All right, so what's the first thing I should do? What? Yes, you should. Factor, factor, factor. So you're going to factor the top. What does the top factor into?
X minus 3 and x plus 3.
Very good. And what does the bottom factor into?
X plus 1 or
Yeah. Why? I got it. Thanks. I don't know why. It's like if I record it, it's almost like it acts worse. So x plus 1 and x minus 3. Okay. Now, look, guys. What do you see up there? Yeah. These two cancel each other out. What does that mean? You got a point of discontinuity.
when 2 cancel out,
That's right. When you have a factor that's on the top and the bottom and they cancel out, that's what creates a point of discontinuity. And it is at when you set that equal to 0 when you solve for x. So it's at 3. Very good. Now,
you're going to find that off like right when you first start.
yes, you can find that right when you first start. Now here's what I'm going to do. I'm going to go mark that on my graph, because if I don't, when I graph, I'll forget. So all I do is, it is where the x is 3, guys. I mean, look at it. It's telling you that. So I'm going to go over here to 3. I just want to lightly on my paper just put some dots. I don't know where my graph's going to be at 3, but I'm going to put some dots that will kind of help me remember that wherever it is, you better stop right there and draw a hole in the graph. Okay? Now,
Do you just write 3 or do we have to write x?
I don't want to write x equals 3 because then it looks like a line. So I am just going to write 3. I know it's a point, so and we're not going to find the point. You can find the point, but we're not going to. Okay, so let me tell you this. When you have a point of discontinuity, that 3 right there still has to be excluded from my domain, because it does still make a 0 in the bottom, but it no longer will be a vertical asymptote. Okay? Now he is a point of discontinuity. All right, so the domain. The domain is the zeros of the denominator. So that's when x plus 1 equals 0, and x is negative 1, or x minus 3 is 0, and x is 3. Okay, so somebody tell me what my domain is. Okay. Union what? Negative 1 to 3. Union 3 to positive infinity. Very good. So I excluded all the zeros in the denominator.
So even though it's point this time, you still have to include it in the
You still have to exclude it from the domain. Because look, he makes a 0. If you put 3 in for x down on this bottom, it's going to make a 0, and that's going to be undefined. Okay? The range, we look at our picture, so we don't have to worry about it. What about vertical asymptote? Zeros of the denominator. So what are they? Yep. Don't put x equals 3, guys. Okay? X equals 3 is no longer a vertical asymptote. He is now a hole in my graph. Okay? So it's only x equals negative 1. So I'll go over here and I'll graph that. All right. Now let's find the horizontal asymptotes. When we talk about horizontal asymptotes, what should you be thinking about? Degree. Degree of the top and the degree of the bottom. What's the degree of the top? What's the degree of the bottom? Okay, so that's that equal representation, right? They're equal to each other, so the top gets to get represented and the bottom gets to get represented. So it's y is equal to, what's the leading coefficient of the top? What's the leading coefficient of the bottom? So my horizontal asymptote is y equals 1. And I'm going to go over here and draw it. What about my slant asymptote? Dallin, with me?
Yeah.
What is a slant asymptote? Doesn't have one. How do you know that? Because it has a horizontal asymptote. It can't have both of these. It can only have one or the other. Or neither. What about an x-intercept? How do I find an x-intercept? The zeros, what? On the top, right? Okay, so what about this negative x minus 3? Is that going to be an x-intercept? Why? Yeah, it's a hole in your graph. It can't be an x-intercept. You see what I'm saying? Okay, so while I had to exclude him on the bottom, I had to still keep him in the game. On the top, I don't keep him in there. So then it's just x plus 3 equals 0. So x is negative 3. So negative 3 is my x-intercept. All right now, do I know what my curve looks like? That's exactly right. He's right here, guys. Okay? How do I find a y-intercept? Put zeros in for the x's. Okay? Zeros in for the x's. So you're going to get 0 minus 9 on the top. On the bottom, everywhere there's an x, guys, it's going to be 0. 0 minus 0 minus 3. So that's just negative 9 over negative 3. And what is that? Positive 3. So my y-intercept is positive 3. So I'll go to the y-axis, 1, 2, 3, and make a dot. Do I know what this part of the curve looks like? I do. Now watch. Everybody look what I'm drawing. Okay, he's going to come down here. When he hits this, what? Do I need anything in my T-chart? My graph is supported by these points over here this time. Okay? I don't have to put anything in my T-chart. I didn't need it. Do what? Bunch of 3s and 1s. Yeah, it is. Just a bunch of 3s and 1s. Okay, so I'm going to show you what this looks like on a calculator. Now, here's what I want to show you. That a lot of times kids will make, the mistake they'll make is that they'll forget that, is that it? Okay, so I'm going to graph it. Here it is. It looks like our graph, right? Now, what if we had forgotten about that point of discontinuity at 3, and we had said that was an asymptote at x equals 3, and you had it drawn on your paper, and then you graphed it? Please tell me when you looked at this graph, you would have said, whoa, wait, I got a problem, right? Because there is no vertical asymptote at 3, okay? So then you could have done some research. Now, that's what's going to happen to the kids that just go, oh, you don't really have to know how to do vertical asymptotes. You just look at your T-chart. Wherever it says error, that's a vertical asymptote. That's not always true, okay? You can see it says an error at -1 because that creates a 0 on the bottom. And you can see it says an error at 3 because that creates a 0 on the bottom, okay? Now, what if I wanted to see, did you see the hole in the graph? No? Right here, at 3, you can't see a hole in the graph, can you? Okay? But I can make it show up, all right, if I rearrange my windows. So I'm going to go to Windows, and I'm just going to, instead of just zooming in, I'm going to go from 2.9 to 3.1. That's honing in on that point, right? Okay? So now look what happens when I graph it. Oh, there's a hole in the graph. Okay? So you can see it, friend.
It's probably something.
No.
But is it ever possible for you not to have an asymptote, like not to have a vertical asymptote?
Yes.
Have a horizontal?
Yes.
Is it possible?
Yes. And I'm going to tell you this too. Sometimes, depending on what they do to those rational functions and some of the things that they put in there, you're going to graph it and you're going to be like, what? It's going to look crazy. The crazier it looks, the more points you need on your T-chart to justify your graph. Sometimes you'll even have a horizontal asymptote and it'll cross it and then approach it on the other side. Okay? Just support that from your T-chart. I mean, you've got a calculator, people. You know, it's not that bad. But just make sure that your graph is supported by your T-chart or your points that you had to find. All right? And then you're fine. But if it does do something weird, you're going to be required to graph more points than if it's just the general accepting thing that we think it's going to do. Okay? All right. Anybody got a question? Okay. So that's point of discontinuity. So the only thing that you've not seen, dadgummit, is a slant asymptote. Okay? I'll get it. So let's do a slant asymptote. Okay. So f of x is equal to x squared minus x minus 2 over x minus 1. All right, let's write all our stuff down. Domain, range, vertical asymptote, horizontal asymptote, slant asymptote, point of discontinuity, x-intercept, y-intercept, T-chart, and graph. Oh, we didn't? Okay, we'll go back and do it. Thanks. I always forget to go back and do the range. Okay, his range. We're not gonna do the hole in the graph, the point of discontinuity. Okay. In another class, you might be required to find out exactly what that y value is, but we're not going to. So we're going to go from negative infinity to what? 1 union 1 to positive infinity. whatever that horizontal asymptote, we went there. Okay? And besides, we're only using 1s and 3s, so that's all we could do. Not really, I'm just playing. Okay? All right. Okay, what are you going to do, smarty pants?
Factor.
Factor. What's the top factor in 2? X minus 2, x plus 1. Okay. The bottom obviously won't factor. Nothing cancels, so what do I know right now? There is no point of discontinuity. So, zeros of the denominator. 1. Okay, so what's my, so what's my domain? Very good. Negative infinity to 1 and 1 to positive infinity. Alright, we'll come back and look at the range. What about vertical asymptotes? Yeah, x equals 1. They are the zeros of the denominator. So we'll go over here and we'll draw it. Alright. Everybody with me? Horizontal asymptote. Degrees, degrees, degrees. That's what you're supposed to think. What's the degree of the top? 2. What's the degree of the bottom? Oh, it's a bad, bad boy. Okay? He's very, very bad. He is top heavy. Okay? Bigger on the top than he is on the bottom. So what does that mean? None.
What does that mean for that?
The degree of the top, 2, over the degree of the bottom, 1. And if the top is bigger than the bottom, then it doesn't have 1. Okay?
But the bottom's bigger than the top, it does have 1.
It has y equals 0. And if they're equal, then that's that equal representation. Okay? Alright. Huh? It's whatever the leading coefficient. Like if this had been a 2 right here, and they were equal, and this were an x squared down here, it would have been 2 over 1 or 2. Okay? I think we did one like that yesterday. Alright. So, now listen to me. If it doesn't have a slant asymptote, does that mean I'll start all over. If it doesn't have a horizontal asymptote, does that mean it has a slant asymptote? No. It only has a slant asymptote if the degree on top is what? 1 more than the degree on bottom. Y'all, if this were a 3 and this were a 1, it would not have a slant asymptote. Okay? But 2 and 1, it's 1 more, so it does have a slant asymptote. How does it tell you to find the slant asymptote? Yeah, you're just going to divide this by this. Okay? Now this one's very friendly because I can use synthetic division. But if the top had been like x cubed minus 4x squared plus 3x minus 6 divided by x squared minus 2x plus 1, you would have had to use long division. Okay? So, synthetic division. Come on. Question? Nope. Okay. So, make sure every exponent's there. 2, 1, 0. And list its coefficients. 1, negative 1, negative 2. What are you going to divide by? 1, the root. Okay? So, always bring down the first one. Multiply. 1. Add. 0. Multiply. 0. Add. Negative 2. Now, what is this number right here? That's my remainder. Okay? Now, a remainder has such a, I don't care what it is. It just has such a tiny, tiny effect on our graph that we chunk it. We don't even think about it. Okay? All we want to think about is what equation we have left right here. Well, if this is an x to the first, then this must be an x, if this is an x to the second, this must be an x to the first. So it is x to the first, and it's plus 0, so it's just x. So what is my slant asymptote? Y is equal to x. Okay? Now, people, you ought to be able to graph a line. What's my y-intercept? 0, right? What's my slope?
1.
So I'm going to go up 1 and to the right 1, up 1, to the right 1, up 1, and to, it's just, guess what, people? It's a slanted line. That's why they call it a slant asymptote. Those tricky math people, you know. All right, how do I find an x-intercept? Huh? Very carefully find the what? Zeros of the numerator. Come on, guys. What's the matter with y'all? Y'all, it's only Thursday. So x minus 2 equals 0. So x is 2. Or x plus 1 equals 0. So x is negative 1. So I have two x-intercepts. I have one at negative 1 and I have one at 2. So here's, now look at this, look at these asymptotes for a second. Let me show you something. When I drew these asymptotes, my brain said, I'm either going to have my curve here in these big fat spaces, or I'm going to have my curves here in these little skinny spaces. Okay? Now, at negative 1 and positive 2 for my x-intercepts, do I know where my curves are? They're in those fat spaces, right? Okay? So, let's find my y-intercept. My y-intercept, people, you just put x zeros in up here. It's negative 2 over negative 1. What is negative 2 over negative 1? So my y-intercept is 2. Can I draw it now? Sure you can. It looks like this big whale or something. And this big whale. Did y'all see on the television where that octopus escaped? Y'all didn't see that? He was in, it wasn't here in the United States, it was like in London or something. And so, yeah, he climbed out of his aquarium, climbed down the front, 10 feet across the floor, and slipped out a little bitty drain into the ocean. It was like Nemo. Pretty cool. He's gone forever. Oh, is it really?
Yeah, that's the funniest game ever.
Yeah.
Well, I want to show you one more thing.
Did you see that Mr. McDonald? When guys heard his zebras escape?
No, his zebras? He has zebras?
Mr. McDonald.
I heard that zebras were mean.
Mr. McDonald, they were running down the side of the house, like, with the cars, they were running on the highway, so I videoed it.
Oh my gosh. Did he get them back?
Yeah.
I don't check them home.
There's no denying who they are.
Like,
I don't think you have
yeah,
very...
I have to spray paint him and everything.
It's a horse.
It's a horse. It's a horse, of course. Okay, so, we just got this one thing left to do. What's this? So, do I need to put any points in my T-chart? I'm glad that people on the video can't see us. Okay? No, you don't. So, all we like is our range. What is your range? Negative infinity, positive infinity. Okay? Now, there's one thing that I want to talk about. So this one's all finished. Everybody okay on that one? All right. So I just want to say, what if, okay? I'm going to use pink. What if my graph had done like this?
It'd be, oh, you're saying like what we
I don't know what happened right there.
That looks pretty
I think my knuckle got too close to it. But anyway, what if it had looked like that? Okay?
That's not the minimum.
Yeah, I wouldn't have, obviously I wouldn't have had an x-intercept, okay? But that's exactly right. Kane says, on my T-chart, I want to know what is this maximum point, and
Would you just have to write it on your graph?
I want it in the T-chart, and what is this minimum point? Now, why am I going to put them in there? It's because I'm standing to the side, and I think my finger keeps getting too close to it. All right, why do I want to put those in there? It makes my graph look good, right? It's going to help you do the range. Your range is going to be for from negative infinity to this max, and then from this min to positive infinity. Okay? All right. Anybody got a question? Okay.